The fear of the Earth being struck by an enormous asteroid has been the source for many science fiction films, but the threat of mankind being wiped out by an impact may be lower than we think. Until now, scientists used the strength of rocks found on Earth to model the damage these giant space boulders would cause. But researchers have now sacrificed a rare sample of meteorites to test the physical properties of asteroids and found they crumbled more easily than expected. Even though space rocks fall to Earth as meteorites all the time, very few are recovered. This means scientists are reluctant to crush them to study their contents and behavior, so use rocks on Earth to test models instead. But questions have been raised regarding the suitability of these materials, researchers from Arizona State University said in a recent paper, in the journal Icarus. The team wanted to find out how meteorites compare with terrestrial rocks, to decide whether Earth rocks can be trusted as an indication of how asteroids would behave. Dr. Desiree Cotto Figueroa and her colleagues crushed two 0.4-inch sized cubes taken from meteorites that had been studied thoroughly. One of the meteorites had fallen in Mexico in 1969 and another landed in Morocco in 2008. The scientists found the cubes were almost as brittle as concrete. They used the strengths and weaknesses of the tiny samples to model what much larger boulders would look like, and calculated those coming from the asteroid belt are much less tough than Earth rocks. Our results suggest boulders of similar composition on asteroids will have compressive strengths significantly less than typical terrestrial rocks, the authors said. The findings from the study could be used to improve methods for protecting Earth from an asteroid strike. This is because the properties of the materials in asteroids are very important when working out how to attempt to deflect large-sized asteroids coming close to the planet, also known as near-Earth objects. Measuring the strengths of asteroidal materials is important for developing mitigation strategies for potential Earth impactors, the researchers said. Each year, roughly 1,500 NEOs are identified, and more than 13,500 have been discovered since the NASA-funded searches began in 1998. NASA has already identified more than 90% of NEOs larger than 0.62 miles, 1 kilometer, and has turned its sights on smaller, football field-sized objects. The crumbly consistency of the asteroids means they are much more likely to fall apart in the atmosphere, and turn into burning fireballs instead of causing huge impact craters. We do see a lot more fireballs than craters, and in fact only the iron meteorites, the strong, dense ones, survive to hit the ground, co-author Professor Eric Asfag, from Arizona State University, told New Scientist. That means we can explain why meteors that are the size of a car break apart so high up in the atmosphere. They are weak, about the strength of cruddy sandstone. Many researchers are looking into ways to protect us from asteroids, including projects like NASA's Reconstituting Asteroids into Mechanical Automata, RAMA, which aims at working out a way to turn the rocks into basic spacecraft using robots. Dr. Daniel Britt at the University of Central Florida in Orlando is not so sure the threat posed by crumbly asteroids is lower. He told New Scientist, "It is clear these are piles of rubble. But that doesn't mean the boulders are strengthless. These guys are just a pain to crush." The findings also complicate matters for protecting Earth, because weaker asteroids would be harder to deflect.